Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers OCR Paper 3. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find the link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on, and more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Write down the mathematical name of this polygon. Now we simply name polygons after the number of sides they have, and this particular polygon has got 1, 2, 3, 4, 5, 6 sides. So a 6-sided polygon, that's just a hexagon, isn't it? So it's a hexagon, even though it's not like a classically looking hexagon. Still got 6 sides. Write down the order of rotational symmetry of the polygon. Okay. So rotational symmetry is if you imagine like putting a pin through the middle of the shape and then slowly rotating it around a full turn. Okay. Now, in how many positions would it look the same when you did a full turn? I think it would look the same in 3 positions as you went round. So I'm going to say that the order of rotational symmetry is 3. Round 32,629 to the nearest thousand. Well, the thousands are this digit here, aren't they? That's the thousands. The 3 is tens of thousands, the 2 is thousands, 6 is hundreds. So I need to round off after that 2. That's the cut point. So everything after that cut line is going to get thrown away. But just before we do, we just need to check out the value of the next digit along, which is 6. And then if it's 5 or more, we need to raise the score. We're going to round up. If it's 4 or less, we need to let it rest. We're going to round down, and in this case it's 5 or more, so I'm going to round this one up, aren't I? So my 32 at the beginning is going to go one up. It's going to go 33. Now 33 is not a good estimate of 32,629. My rounded number has to have the same magnitude. That 3 at the beginning was tens of thousands, so we need to make this number tens of thousands again just by adding some extra zeros on the end. Okay, so just check your answer is the same magnitude as what it was to start with. 33,000. Next we need to round 32,629 to one significant figure. Now the first significant figure is the first non-zero digit of your number. That's the 3. Okay, so in this case we're going to be rounding off right after the 3. Okay. Now the next digit along is this time is a 2, which is 4 or less, so we need to let it rest. We need to round down in this case. Okay, so the 3 at the start is going to stay being a 3, and we're just going to then add on enough zeros to make our answer the same magnitude as it was to start with. So adding 4 zeros, I'm going to get 30,000. Okay, another way of thinking about it is the first significant figure is in the tens of thousand column. So just round your number to the nearest 10,000. So you can see that 32,000 is closer to 30,000 than 40,000. The line AB is shown on the coordinate grid. Yes, it is. Part A says write down the coordinates of the point A. Well, the point A is one labelled A up here. And the coordinates are along the corridor up the stairs, aren't they? So 1, 2, 3, 4 along and 1, 2, 3, 4, 5, 6, 7, 8, 9 up. So this is coordinate 4, 9, isn't it? Okay. Part B, we want the coordinates of B as well. So to get to B, we're going to go 1, 2 to the left, which is -2, and then 1, 2, 3 down, which is -3. So to the left and downwards is negative. So -2, -3, isn't it? Okay. And then part B says plot point C on the grid at 7, -2. Well, 7, -2 is going to be like 7 along, take me to there, and then 2 down. So it's going to be this point here. That's the point C. I'm going to label it C. Let's get rid of that bit. And then part C says the equation of the line AB is y equals 2x plus 1. Okay, a line parallel to AB goes through the point 0, 4. Write down the equation of the parallel line. Okay, well, the point 0, 4 is this point here, isn't it? Okay, and if I was to draw the line parallel to AB, it's quite easy to do on my computer thing because I can just get the gradient to match and then push my ruler up a little bit. You see? Okay, so that's the line parallel to AB going through the point 0, 4. Well, the equation of a straight line can be written in the form y equals mx plus c. And for the original line, m is the gradient, and the gradient is 2. So that's where the 2 goes in there. And the y-intercept of my line is c. So you can see that this line has a gradient of 2. So for every 1 unit you go along, you go 2 up, 1 along, 2 up, 1 along, 2 up. So that's why it's got a gradient of 2. And the y-intercept is 1 because the line passes through the y-axis at the value of 1. Okay, so the equation of this line then is y equals 2x plus 1. Now the parallel line to that has the same gradient. So for every 1 you go along, you're going to go 2 up. So the equation of that line starts out the same way, y equals 2x, because it's got a gradient of 2. But the y-intercept is different. The first line passes through the y-axis at 1. The second line passes through the y-axis at 4. So this is the line y is equal to 2x plus 4. Okay, so that's the line we're looking for. We're looking for the line y equals 2x plus 4. But a theme park asked 900 people to choose their favorite activity from a list of 5. The pictogram shows the result for 4 of the activities. So we've got thrill rides, family rides, entertainment, children's rides, water rides. And we can see here that this key to this is that like a little grid like this with 4 little cells represents 100 people. Okay, so then how many people chose entertainment? Well, if one of these represents 100 people, look, then in entertainment I've got 1, 2 of those. So that's going to be 2 lots of 100. It's going to be 200. Part 2 says, how many more people chose the water rides than the family rides? Well, the water rides, it's got 2 whole of one of those grids, and then it's got this other weird one here. So this one, this grid is divided up into 4. So if each one of these grid is worth 100, then one of the cells within that grid is worth going to be 25, then, isn't it? So this is going to be worth 25, 25, 25. I don't think that line should be there. It kind of came out weird when I printed it. So it's actually just 3 of those things. So it's 25, 25, and 25. So that means that one there is worth 75, and that's worth 100, and that's worth 100. So altogether, that's 275, isn't it? Water rides is 275. Family rides, again, I've got 1 whole one, which is worth 100, and 1 of these quarter parts, which is worth 25. So that's 125, give me 125 altogether. So how many more people more means the difference between the two, doesn't it? So to find out how much more it is, I'm going to have to subtract one from the other. So 275 take away 125. That's got a difference of 150, isn't it? So that's 150. 150 more people chose water rides than family rides. And then finally, all 900 people chose one of the 5 activities. Complete the pictogram for the children's ride. So the children's ride hasn't been put in there. Okay, so let's just count how many we've got for the other rides. So we already worked out that entertainment was 200. We wrote that down for part A. And then thrill rides we haven't looked at yet, but that's got 100, 100, and 25 and 25. So that makes 100, 150. So that's 250, isn't it? So what we've got all together so far, we've got 250, 125, 200, and 275. That adds up to, well, you can type it into your calculator if you like. I'm just going to quickly do it in my head. 275, 300, 400, 500, 600, 850. So that adds up to 850. So if I then take 850 away from 900, 900 take away 850, that's going to be what's left over for the children's rides. That's 50. So to represent 50, I'm going to have to use half of one of these like little grids, aren't I? So not a whole grid, just like a half of one, like that. Okay, that should do the biz. So that represents 50. If I was in an exam, I'd probably use a ruler to draw those boxes, but you know, it's not so easy on my computery thing, so I'm just going to sketch it in today. A circle has radius 5 centimeters. Work out the circumference of the circle. Okay, so I've got a circle. Radius is the distance from the center to the edge. That's the radius. So this has got a radius of 5. Okay. So then to work out circumference, cherry pie delicious, apple pies are 2. Okay, then my two formula for circles. Cherry pie delicious, circumference equals pi times diameter, area, apple pies are 2, area equals pi times r squared. It's just a silly way of remembering it. So cherry pie delicious, apple pies are 2. Now in this case we want circumference, don't we, which is this one. But this one is, it's in terms of d, isn't it? There's another way of writing this. There's two approaches here. We could just work out what d is. D is 2 lots of the radius. It's going to be 10, isn't it? It's going to be twice as long as the radius. Or you can use 2 pi r as well. That's another formula you can use. Okay, I'm just going to convert or find d. D is 10. Diameter that is, and then sub it into my formula. So c equals pi d equals 10 lots of pi then, isn't it? So pi is 3.14, so that's just going to be 31.4 what? 31.4 centimeters. It's just in flat units, isn't it? So 31.4 centimeters, you could do that on your calculator. I just happen to know that pi was 3.14, so it just saved me typing it in. Work out the area of the circle. So we did the circumference one first. Now it's time to move on to the area one. Area equals pi r squared. Apple pies are 2. Then subbing in, this time r is 5, so it's going to be pi times 5 squared, isn't it? So 5 squared times pi, which is 25 pi. What's that? Tap that into the calculator. So 25 times pi. You've got a little pi symbol on your calculator, so just use that. So that's 78.5 and change according to my calculator. Just going to round it off to 3 significant figures. 78.5. Let's write the following numbers in order of size, smallest first. Okay, so I like to try and compare these digit by digit, moving from left to right. So now they all start with a 0. That's the same for all of them, isn't it? And actually the next digit along is the same for all of them as well. Okay, they all got a 5 there. Then things get different on the next digit, don't they? So on the next digit along, we've got a 2, a 4, a 1 and a 0, and that's what I'm going to rank them on then. I'm going to rank them on that digit. So the smallest one first is the one with the 0 in it then, isn't it? So that's 0.502. That's my smallest one. The next one is going to be the one with a 1 in it, so that's 0.51. And then I'm going to look at the one with a 2 in it, which is 0.529. And then I'm going to look at the one with a 4 in it, so that's 0.54. Okay? So just make sure you're comparing light digits with light digits when you're doing these. Katie is facing north. She does a 3/4 turn anti-clockwise. She then turns 135 degrees clockwise. What direction is she now facing? Okay, well, now remember you're going to have a clock in the exam room, aren't you? So you can have a look at which way round the hands are going if you can't remember. But anti-clockwise is that way round, and clockwise is the way the clock hands are going, that way round. So if we are turning 3/4 turn anti-clockwise from north, we're going to end up doing a 3/4 turn around to this direction, aren't we? If she then does 135 degrees clockwise turn, we're going back the other way, aren't we? The way we just came. Now 90 degrees is a right angle and 180 degrees is a straight line. So 135 degrees is somewhere in between. It's going to be about like that, isn't it? That's 135 degrees. What direction is she now facing? Well, the angle between there and there is 90. So if I add on the 135, 90 plus 135 gives me an answer of 225. So she's on a bearing of 225 degrees. And Jenny has a 5-sided bias spinner. The sectors are coloured red, blue, green, yellow and white. She spins the spinner 100 times. The table below shows the number of times the spinner lands on each colour. So the colours are red, blue, green, yellow and white, and you can see that they've landed on various colours various numbers of times. Jenny uses her data to estimate the probability of the spinner landing on each colour. Write down Jenny's estimate of the probability of it landing on red. Okay, so you can work out like a practical version of probability. We call it relative frequency. By taking the number of successful trials, which is in this case 28 for red, and dividing it by the total number of trials, which in this case is 100. So 28 divided 100, that is 0.28, isn't it? And so that is a rough and ready approximation of the probability of landing on red. Now obviously with 100 trials, probability being as it is, it might, the actual true value might be slightly more, slightly less than that, but it's going to be close to it. Okay, for part B, Jenny then writes in some of the colours on this probability scale. So she's written in yellow at 0, which is correct. Look, because yellow, there were 0 outcomes out of 100. So it's hard to believe there was any yellow on there if none of them came up in 100 throws. So yellow is pointing at 0, which is impossible. Now the next one along is between unlikely and evens. If you think about this scale, there are how many jumps between one end and the other? So there's 1, 2, 3, 4, 5, 6, 7, 8. So each one of those is an eighth, or quarters in between, aren't they? So unlikely, that's at 0.25, that's at 0.5, that's at 0.75, and that's at 1. So this arrow is pointing somewhere between 0.25 and 0.5, and it's actually closer to 0.5. Well, halfway between 2.5 and 5 is about 0.37. So I'm guessing that must be the blue one then, mustn't it? Because the other two, the red and, well, the other three, the red, the green and the white, are going to be further down. They're going to be below, well, just a little bit above the 25, aren't they? 0.25, not all the way up here. Okay, so this one I think is going to be the blue one. Right, explain why Jenny's estimate for the probability of landing on yellow cannot be the actual probability. Well, if you remember at the start of the problem, it was described as a 5-sided spinner, bias spinner. So it's kind of weighted to one side. So when you spin it, it's more likely to land on one of the other colors than it is to land on yellow. But presumably, if yellow is one of the kind of corners of your spinner, if you think about the spinner, so it's kind of, maybe it's got like a weight on this side, which means if you were to spin it, it's more likely to fall this way. But you know, if yellow was over here on this side, it's going to be less likely to land on it, but it's not going to be impossible, is it? Okay. It's just going to be very, very unlikely, which is why she hasn't rolled on it already. I'm guessing that's the sort of answer they're looking for. So, cannot be the actual probability. 0 would imply that it is impossible to get yellow, but as it is one of the sides of the spinner, it must be possible, although unlikely, to land on it. Okay, so that's my reason. Okay, so it didn't land on yellow in any of those because it does favour the other colours quite strongly, but presumably, you know, if there's some sort of freak wind, it might just kind of fall over onto the yellow at some point. Simplify 3a plus 7b minus a plus 4b. Okay, so we need to collect like terms. So we've got terms in a, 3a minus a, and we've got terms in b, plus 7b and plus 4b. Now notice when I highlight those I highlight the sign that goes in front of them, because that is part of what we're doing, isn't it? So 3a subtract a is 2a, and 7b plus 4b is 11b. So we get 2a plus 11b. 8b, expand 4 lots of 2d plus 5. So single brackets, a number on the outside, that gets multiplied by everything inside the bracket. So 4 times 2d is 8d, and 4 times 5 is 20. There's a plus sign in the middle, so it must be plus 8d plus 20. Finally, we're asked to factorize 15x plus 18y. Now that's pretty much the opposite of what we were just doing. Expanding removes brackets and factorizing puts them back in. The thing that goes on the outside of the bracket is the thing that's common to both terms. So we've got an x in one and a y in the other, so they're not common, but we've got a 15 and an 18. 15 and 18 are both in the 3 times table, so I can put a 3 on the outside. Now, to work out what goes on the inside of the bracket, we just need to think about, well, what 3 times what is going to give me 15x? Well, 3 times 5x gives me 15x. We're going to have a plus in between. And 3 times what gives me 18y? Well, 3 times 6y must give me 18y. So I get 3 lots of 5x plus 6y. List all the factors of 30. Okay, now when I find factors, I like to start with either ends and then work to the middle. So I will start writing these down in pairs, starting from with 1 and 30. So 1 times 30 is 30. Now I'm going to try 2. Does 2 divide 30? Yes, it does. 2 times 15. 3. Does 3 divide 30? Yes, it does. 3 goes with 10. Try 4. Does 4 divide 30? Nope. Try 5. Does 5 divide 30? Yes, it does. 5 times 6 is 30. Now you notice now we've kind of met up with the numbers coming down the other end, so I'm pretty confident that we found all the pairs. So the pairs are then 1, 2, 3, 5, 6, 10, 15 and 30. Part B says a factor of 30 is chosen at random. What is the probability that it's a 2-digit number? Okay, so probability is defined to be successful outcomes divided by total outcomes. So we just worked out all the factors of 30 and we found that there were 8 altogether. So there are 8 possible factors that you could pick. Now, how many of those factors have got 2 digits? Okay, well, it's 10, 15 and 30, those 3. So there would be 3 successful outcomes out of a total of 8 outcomes. So the probability is 3/8. Jack and Liam each get the same pocket money. Jack spends 75% of his and has £2 left. Liam spends 40% of his. How much does Liam have left? Well, if Jack spends 75% of his and he gets and he's got £2 left, then 25% is what he has left, isn't it? And that is equal to £2. So if 25% is equal to £2, then 100% is going to be 4 lots of that, then, isn't it? Okay, and 4 lots of £2 is £8. So that means that Jack must have had £8 pocket money to start with. Now we know that Liam has the same amount of pocket money, so he must also have £8. So if he spends 40%, then he's got 60% of his pocket money left. So what we need to do is to find what 60% of 8 is. So using our triangle, final, original, multiplier. Our final is what we're trying to find. Our original is £8 and our multiplier, let's say we want to find 60%, don't we? 60% of the amount, which has a multiplier, is 0.6. So to find our final, just cover that up, is original times multiplier. Final is equal to original times multiplier. So 8 times 0.6, which is, according to my calculator, 8 times 0.6 is 4.8. Now remember, this is money though, so we're going to have to write that as pounds and pence. So he's got £4.80 left. Now you could have also found out what 40% was and deduct it from the £8 to get the same answer if you wanted to, but this way is quicker if you know what you're doing. Sandip is going on holiday. She wants to change £400 into euros. Bank A will change her £400 into 452 euros. Bank B changed £250 into 280 euros for Sandip's friend. It will use the same rate to change Sandip's £400 into euros. At which bank will Sandip receive the most euros, and by how many? Show your working. Okay, so we know what's going on in Bank A. We just really need to work out what's going on in Bank B, don't we? Now, Sandip's friend took £250 and she changed it into 280. So we can use those two figures there, that one and that one, to work out the exchange rate. So the exchange rate is going to be, well, let's take the 280 and divide it by 250, and that will tell me how many euros I'm going to get for each pound. Okay, so the exchange rate is 280 divided by 250. That comes out to be 1.12, which is basically £1 then is going to get you €1.12. Okay, so then if I then have £400 to change, I'm going to take my €1 and 1.12 euros and I'm going to times it by 400, and that's going to give me 448. Okay, so 448 euros from Bank B. Now we got 452 from bank A. So bank A is going to give her the most, okay, by how much difference is going to be what she got in bank A, 452, minus what she gets from bank B, 448, and that comes out to be 4. So Sundip received €4 more. Okay, might buy her a, drink at the bar or something. Ben and Sundip are making pancakes using the ingredients below. Ingredients to make 12 pancakes: 75 milliliters of water, 200 milliliters of milk, 100 grams of flour, 50 grams of butter, and 2 eggs. Now the ratio of the amount of water to the amount of milk needs to be 75 to 200. Write this ratio in its simplest form. So if I've got a ratio of 75 to 200, these cancel down pretty much the same way as fractions do. You've got to look for common divisors that you can divide through by. Now I know that 75 and 200 are both divisible by 25. So if I divide both sides by 25, if you don't spot 25, you might spot 5 and then do it a second time to cancel it down a bit more. But I could see that 75 had 25 in it, so yeah, I could do it straight away. So 25s into 75 go 3 times. You've got 4 25s and 100, so you're going to have 8 and 200. So that cancels down to 3 to 8. Okay, so I think that's in its simplest form. 3 is prime, and it doesn't go into 8, so 3 to 8 is our simplest form. Part B says Ben makes 18 pancakes. Work out how much flour he needs. Okay, well, if I make a ratio of pancakes to flour, then I know from the original recipe that for 12 pancakes we needed 100 grams of flour. So I can write down 12 to 100 here. Okay, now what I want to do is change 12 pancakes to 18 pancakes. Now I can't just multiply 12 by something to get 18, okay, but I can go by a stepping stone to make the maths a little bit easier. So if I first find out how much it is to make 6 by dividing by 2, I can then scale that up by a factor of 3 to find 18. I think that's going to work easier with my 100 on the other side, isn't it? So on the other side, if I divide 100 by 2, I'm going to get 50. So for 6 pancakes, I need 50 grams of flour. And then taking that 50 and scaling up by a factor of 3, then 50 times 3, that's 150. So for 18 pancakes, I need 150 grams of flour. Okay, then Sundip has 225 grams of butter and 10 eggs. She has plenty of the other ingredients. Work out the maximum number of pancakes that she can make. So which one is going to be the limiting factor? Is she going to be more limited by the amount of butter, or is she going to be more limited by the amount of eggs? Okay, well, at the moment, we know that pancakes to eggs is 12 pancakes for 2 eggs. So then if I wanted to, if I have 10 eggs, that's 5 times as many as that, isn't it? Okay, so 5 times 12, that gives me 60. So I've got enough eggs to make 60 pancakes. But that might not be the limiting factor. I might be limited on the butter. So let's just double check the butter as well. So for the butter, we've got 12 pancakes it requires 50 grams of butter, and we've got 225 grams. Okay, so again, it might be helpful to go by a stepping stone, because 50 doesn't go directly into 225. But if I halve it first to get 25, then I can easily scale it up to 225 after that. So dividing 50 by 2 will tell me how much pancakes I can make with 25 grams of flour. So that's 6, isn't it? I can make 6 pancakes if I divide 12 by 2. I'm going to get 6. And then taking 25 and scaling it up, how many 25s go into 225? Well, it's going to be 4, 8, 9 times, isn't it? So times that by 9. I should know that gives me 225. So doing times it by 9 on the other side, 6 times 9, That's 54. Okay, so I've got enough eggs to make 60 pancakes, but I've only got enough butter to make 54. So that's going to be the limiting one, isn't it? You know, I've got enough. If I've got enough eggs to make 60, then I've got enough eggs to make 54. But if I've only got enough butter to make 54, then I don't have enough butter to make 60. So 54 is the maximum I can make then, isn't it? So 54. Use trigonometry to work out the size of angle X. Okay, right, so trigonometry is a right angle triangle, so it's about Soccer, isn't it? Is that how you remember it? Now, easiest thing to do is just label up the sides first. Here's my angle down here. So that means, well, that's the longest side, isn't it? So it's the hypotenuse. This 9 joins onto it, so it's the adjacent, and that makes the other side the opposite. So I have been given the adjacent and the hypotenuse, and I want X. So the ratio that includes the adjacent and the hypotenuse is that one there. Cosine. So let's write that out fully then. The cosine of an angle is equal to the adjacent divided by the hypotenuse. Okay, that's the full ratio that we need to use. So then let's sub in what we know. Cos, well, it's x in this case, not theta. Adjacent is 9 and the hypotenuse is 10. Okay, so the cos of x is 9/10. So then x is going to be the inverse cosine of 9/10. Okay, so that, reaching for the calculator, shift cos 9 divided by 10 comes out to 25.84, which we're just going to round off to one decimal place, 25.8. Shape is made by joining a right angle triangle to a rectangle. Okay, and then we need to work out the area of the shape. Okay, so we've got two different shapes. We've got area 1, which is a triangle, and we've got area 2, which is a rectangle. Okay, so let's work out area 1 first. Area 1 is a triangle, so triangles normally have an area of half base times height. Now, base doesn't have to be the one on the bottom. Just your base and height need to be at right angles to each other. So I can use this side here as the base, and I can use this side here as the height because they are at right angles to each other, and so that would be perfectly acceptable for finding the area. So then that is going to be a half times 30 times 16, just subbing those values into my equation, and then half of 16 is 8, and 8 times 30, 3 8s are 24, and a 0, that's 240, isn't it? So that's going to have an area of 240 centimeters squared. What about A2? A2 is slightly more problematic because, well, it's a rectangle, it's got easy formula for finding it, but we only know one of them so far, don't we? We know this length here is 52. Okay, so one of them is going to be 52, but what is the other one? We don't actually currently know this one, do we? Okay, we haven't got that one. But you can see that that side there, which is going to be the width of this rectangle, is the hypotenuse of that right angle triangle, isn't it? So I can just use Pythagoras Theorem to find this one. Okay, so here I can use c squared equals a squared plus b squared, where a is 30 and b is 16. Okay, so what's that then? 30 squared plus 16 squared comes out to be 1156. Okay, so then c is going to be the root of that then, isn't it? Root answer, that's 34. Okay, so that means my hypotenuse is 34, so that's 34, so that's 34. Okay, so subbing that into my calculation here, 52 times 34 times that by 30, 52, going to get 1768. And so then the area is going to be those two things added together then, isn't it? So it's going to be 240 plus 1768. That comes out to be 2008. units, centimeters squared. 240 people go to a rugby match. 183 of the people support the home team and the other people support the away team. 162 supporters are male, 45 of the away supporters are male. Complete the frequency tree. Okay, so every kind of level of the frequency tree is going to have to add up to 240. So I've got 240 in my first kind of level, and then I've got home and away. So my 183 and whatever appears here has to add up to 240. So 240 subtract 183 gives me 57. So there are 57 away fans on the day. Now, of those 57 away fans, we know that 45 are male. So 57 subtract 45 leaves me 12 that are female on that date. Okay, so I've just got these male and females from the home team to place. Now, I was told something about that earlier. I was told that 162 of the supporters are male, and we already know that 45 are away fans. So the rest of those males must be home fans. So what is 162 subtract 45? That is 117. So that means that I must have 117 male home fans. Okay, now I know that I've got 183 home fans, of which now I know that 117 are male. So if I take 183 and I subtract 117, it leaves me with 66. So that means I've got 66 home female fans. That's it, my table's complete. Let's rearrange this formula to make W the subject. So again, just as I was saying, you can see that you've got 3 unknowns in here rather than just 1. So it is a formula and not just an equation. If we want to make W the subject, we need to rearrange it so that I get W by itself. Now you can do this very much the same way as you do equations, by kind of adding, subtracting, multiplying, dividing things from both sides. Okay, so we want to try and isolate W, which means we want to try and get rid of everything else. Okay, now at the moment W is times by 2 and I've got 2h added to it. Now the order that you do this is like BIDMAS but backwards. So if you think about BIDMAS, then I've got a multiplication in here and an addition. So multiplication comes before addition normally in BIDMAS, but when you're rearranging these you kind of go through BIDMAS backwards because you're kind of using inverse operations to work your way through. So that means I need to deal with the addition first. Now the opposite of adding 2h is subtracting it. So if I subtract 2h from both sides, it will cancel off this side, and what I'll get is p minus 2h is equal to 2w. Okay, and then now I've got 2w by itself, but I want w by itself. So I'm going to divide both sides by 2. That side is going to cancel with that one there, so I'm going to leave me with w on the right, and I'm just going to get p minus 2h over 2 on the left. Okay, that's all I'm going to do. Well, that's kind of the answer. I'm just going to spin it around actually and write w at the front. So w is equal to p minus 2h over 2. That's my final rearranged answer. And the height h of a lorry is 4.3 meters, correct to 1 decimal place. Complete the error interval for the height h. Okay, now I like to do these with the number line. I draw a number line and I mark on the number that they've given me, which is 4.3. Okay, so then we know it's correct to 1 decimal place. If I was drawing a scale and that was going up in numbers to 1 decimal place, then the next one up on the scale would be 4.4, and the one below it would be 4.2, wouldn't it? It'd be 4.2, 4.3, 4.4. Now the numbers that round to 4.3 are going to be the numbers that are halfway between 42 and 43 or nearer, or halfway between 43 and 44 or nearer. So basically this range of numbers are the numbers that round to 43, aren't they? Okay, but what number is halfway between 42 and 43? Well, I know that that is 40, sorry, not 42 and 43, 4.2 and 4.3. It's 4.25. If you're not sure, you can just add the two numbers together and divide by 2, and that would tell you on your calculator. And the other one then is going to be 4.35. That's halfway between 4.3 and 4.4, isn't it? Okay, so my lower bound is going to be 4.25 and my upper bound is going to be 4.35. So any numbers between 4.25 and 4.35 round off to 4.3 to one decimal place. Question 17. The table below shows the area in square kilometers squared of some countries. Now you can see these areas have been given in standard form. There's a number times the power of 10, isn't it? Write the area of Sweden as an ordinary number. So in the table, Sweden is given as this, 4.5 times 10 to the 5. Okay, so 4.5 times 10 to the 5. If I want to write it as a normal number, I could just type that into the calculator and work it out, or I can work out where the decimal point goes. Times 10 to the 5 will have the effect of shifting the decimal point 1, 2, 3, 4, 5 jumps along. It will go to here, okay, which means there are going to be some extra zeros appearing in here. So my answer is going to actually be 450,000. What's that? That's 450,000, isn't it? Okay. The other way of thinking about it is 10 to the 5 is hundreds of thousands. 10 to the 6 is millions, isn't it? Okay, so that's 450,000. Part B says, which of the countries has the smallest area? Well, the smallest area is going to be the number with the smallest power of 10, isn't it? So if you have looked down those lists, you should know already that Luxembourg is a pretty teeny tiny country, and so is Singapore. So it's going to be out of those two, but if you look, 10 to the 2 is smaller than 10 to the 3. It's definitely Singapore. Singapore is just a teeny tiny island. Part C, Alexa says the area of Australia is approximately 3 times larger than the area of Luxembourg. Is she correct? Show how you decide. Well, just from common sense, I know she is ludicrously wrong. Australia is huge. But anyway, let's look at the maths. So you might think, if she was looking at this, she might be thinking, well, 2.59 times 10 to the 3, which is Luxembourg, isn't it? That's Luxembourg. If you just have a look at the mantissa part, the number at the front, then if you took 2.59 and times it by 3, you would get something around 7.69, which is the mantissa part of Australia. But Australia is 10 to the 6. So that is nowhere close. So Alexis is wrong. And the way you can do that, you can just maybe divide one by the other, can't you? So if you type into your calculator 7.69 times 10 to the 6 divided by 2.59 times 10 to the 3, it will tell you how much bigger one is compared to the other one, won't it? Now, to do that on your calculator, you want to be using the times 10 to the x button down at the bottom here. So when I type in the Australia one, I'm going to type in the mantissa part, 7.69, and then I'm just going to press that key there once. That's going to give me the times 10, and then I'm going to put in the power, which is 6. So 7.69 times 10 to the 6, divide by, then the second mantissa, which is 2.59, and then I'm going to press that 10 to the 6 button again, and I'm going to put in the power, which is 3. Okay, and that comes out to be 2969. So that's equal to 2969 and change. Okay, so Alexa's wrong because Australia is almost 3,000 times bigger than Luxembourg. Okay, you don't have to write equal if you don't want to. Right, so Australia is almost 3,000 times bigger. I didn't write my 3 very well either there. 3,000 times bigger than Luxembourg there. Okay, work out the total area of Russia and Australia. Give your answer in standard form to two significant figures. Okay, so I'm going to add these two together. Again, it's a calculated paper, so I'm just going to use the calculator function to do it. So 1.71 times 10 to the 7 plus Australia, which was 7.69 times 10 to the 6. So again, I'm just going to use that calculator button on the for powers for standard form on the calculator. 1.71 times 10 button. Type in the power, which is 7, plus 7.69 times 10 button. Type in the power 6, and that comes out to be 2479.0000. So that's equal to 2479.1234 zeros. Okay. Now, what is that in standard form? What's it in standard form? Okay, so in standard form, the decimal point is currently here. So if I was going to move it between the 2 and the 4, it would go 1, 2, 3, 4, 5, 6, 7 jumps, wouldn't it, over to there? So that means it is 2.479 times 10 to the 7. But that's not two significant figures, is it? That's four significant figures. So to round it to two significant figures, I'm going to round it off after the 4. Next number is a 7, so I'm going to round it up. That makes it 2.5 times 10 to the 7 to two significant figures. Okay, so I just rounded it off there. 2.5 times 10 to the 7. Okay, so 3x minus 8 is equal to 19. Okay, so I've got 3x minus 8 is equal to 19. Now, if I want to solve it, that means to find the value of x. So we need to get x by itself. Okay, now I can do that firstly by adding 8 to both sides. That's going to get rid of that 8 on that side, because negative 8 plus 8 is 0. So that is going to give me 3x is equal to 19 plus 8, which is 27. And the next thing I can do to try and get x by itself is to try and divide both sides by 3. Then 3 divided by 3 is just going to leave me with the x, and 27 divided by 3 is 9. So that tells me that x is equal to 9. That's my final answer, 9. That gives us a distance time graph showing the journey of a toy train. And underneath we have 4 possible descriptions of the first 2 parts of the journey. Now let's have a look at the first 2 parts of the journey. This first part here is a straight line, and it is increasing as time increases, so it's sloping upwards. So that indicates that the toy is moving at a constant speed. And then the next part, the distance isn't changing for a period of time, so that would indicate that the toy train is at rest. So which one of the descriptions most accurately displays that? So it must be B, moves at a constant speed and then is stationary. Okay, for part B, it says work out the average speed for the last 4 seconds of the journey. So average speed, if you remember your DST triangle, average speed is equal to distance travelled divided by time taken. And from our diagram, the last 4 seconds is this part of the graph. Well, we know the time. The time is the 4 seconds. So this is how much time it takes, 4 seconds. And the distance travelled then is going to be the distance from 4 to 10, which is a distance of 6 meters. So it's gone 6 meters in 4 seconds. So then average speed then is going to be our 6 divided by 4, which is 3/2 meters per second. Has helpfully given us the formula for the volume of a sphere, which is 4/3 of pi r cubed. We're told that a still sphere has a radius of 9 centimeters. So from here to here is 9. Work out the volume of the sphere. So this is just really subbing into that formula. So volume is equal to 4/3 pi r cubed, which is 4/3 of pi times 9 cubed. It's a matter of really typing that into the calculator. So 4 divided by 3 times by pi times by 9 to the power of 3. I make that 3053 and change. So I'm just going to, I'm going to round off 3053. I'm just going to round off to the nearest whole unit. Which would be 4 then, wouldn't it? In part B, we're told that the density of the steel is 7.8 grams per cubic centimetre. Work out the mass of the sphere. Well, density, the formula for density is mass over volume. So rearranging that, so make mass the formula, and mass the subject, sorry, and mass equals, we're going to take this and cross multiply it up here. So mass equals density times volume, which in this case is going to be our 7.8 grams per cubic centimetre multiplied by, just checking the units all the same, yeah, that's in centimetres, so 3054. Now I've still got the stored calculator value on my calculator, so I'm just going to carry on using that. So I'm going to take the answer and I'm going to times it by 7.8. And that gives me 23,818. Complete the table for y equals x squared minus x. Okay, now with these tables that you need to complete, the easiest way is to use the table mode on your calculator if you've got a Casio. If you don't have a Casio, you really want to get one of these because they've got lots of features that are very handy for your exam that you miss out on otherwise. So if you tap on mode and go to table, then you get f of x is equal to displayed on your screen. So it uses a slightly different notation. F of x is the same thing as y basically. So y is equal to, and then we just type in the bit on the other side of the equal sign, x squared minus x. Now to type in the x, you need to press the alpha key, and then the x here is above the bracket. So x squared minus, and then alpha x again. Okay, so x squared minus x. Press enter. You're going to get g of x appear. Now we've only got one function to type in this time, so we can leave that one blank for now, and then press enter again. Then the start value is going to be, well, I would go for, either look at the table. If it gives you an x value, fine. If it doesn't, then what you can do is just look at the x-axis on your diagram and then pick out the number on the far left and the far right as your start and end values. So I'm going to be starting at -2, I'm going to be ending at 3. Now the step is what we're going up in this case. You can see here we're going up in ones, so we're going to go up in ones, and then press enter. You can see I'm going to get a nice table displayed with all the values in that I need. Okay, so on my table then, the first box is -2 goes with 6, so I'm going to put in my -2 in there, and then I've got -1 goes with 2, so -1 goes with 2, 0 goes with 0, which matches, 1 goes with 0, 0, 2 goes with 2, and 3 goes with 6, so the rest all matches. Okay, so we filled out the table, and that was really easy. Just make sure you use the table because it does make life a whole lot easier. Part B, the graph of y equals x plus 1 is shown on the grid. It's already drawn. On the same grid, use part A to draw the graph of y is equal to x squared minus x for the values of x from -2 to 3. So basically we just need to plot those points, and don't we? Okay, so -2 goes with 6. minus 2 goes with 6, so that's a point there. Minus 1 goes with 2. 0 goes with 0. 1 goes with 1. 2 goes with 2. And 3 goes with 6. Okay. Now, this is a quadratic curve. It has a nice smooth parabola between the points. That's what you're going to be drawing on this shape. Okay, so it's a curving thing. Should be symmetrical on both sides. Now, it doesn't have a flat bottom, so it will dip below the axes between 0 and 1, and then start coming back up again. Okay. Now try and do a smooth line. It doesn't matter if it's a little bit wobbly, okay, but what you shouldn't have is feathering, so not multiple lines, and you need to try and skewer each of your points. So do try and go through each of the points you plotted. Okay, so a little bit of wiggle is not important, but you know, nailing the points and not doing multiple lines between points is that's what you're going to actually lose mark for. Now the last point says write down the x coordinates of the point where the two graphs cross. Now you can see they cross in two places. They cross here, look, and here. Now we want the x value, so if I just get a ruler and I read down to the axes, it's probably the easiest thing. Over here. Okay, so the first one looks slightly to the right of like a -1/2, but only ever slightly, and so I'm just going to leave it as -0.5, and then the other one is slightly to the left of 2.5, but not enough for me to change the value again. So I'm just going to put in -0.5 and 2.5. So -0.5 and 2.5. Okay. And I think we're done. Question 7. Sam types a constant number of words per minute. He takes 8 minutes to type a report of 416 words. How long does it take him to type an essay of 1,534 words? Give your answer in minutes and seconds. Okay. So I think what I'm going to do is just going to convert minutes into seconds to start with, because otherwise it's going to be difficult to calculate with. So 8 minutes. I can just type that into my calculator actually. So 8 times 60, that's 480 seconds, isn't it? So I can write that as a ratio, can't I? So if I do time to words as a ratio, so I know then it took him 480 seconds to produce 416 words. Okay, now I want to know how long it's going to take him to produce 1,534 words. So I can use something called the unitary method and go via 1, okay, by dividing by 416 and then multiplying by 1,534. If I do the same thing this side, so 480 divided by 416, okay, that comes out to be, well, 15 over 13. I might just write it down as 15 over 13 because it'd be quicker. So 15 over 13, and then multiply that by 1,534. I get 1,770. Okay, so that means it takes 1,770 seconds in order to type that amount of words. Now, what's that in minutes and seconds? So to convert that into minutes and seconds, I'm going to divide it by 60. Okay, now that's probably going to give me a horrible answer. Oh no, not that horrible. But then if I then press the hours, minutes and seconds button over here, you can see it's going to convert it into 2930, which is 29. So that's going to give me 29 minutes and 30 seconds then as my answer. 3 straight lines are shown. Work out the value of x. Okay, well, they aren't just any old 3 straight lines, are they? We've got 2 lines here that have got arrows on them, which means that these are parallel lines, and we've got a line crossing them. And whenever we've got that situation going on, it forms various angles, and there are relationships between various angles that are formed. Firstly, if you have a think about that angle there, it is vertically opposite this one, which means that those two are equal. So that one must also be 2x plus 15. And similarly, this angle and this, so that one and that one are equal, but also that one and that one must be equal because they are what we call corresponding angles. So in other words, 2x plus 15, the angle up there must be the same angle as 3x minus 38. Now they might look different because they're written algebraically using different expressions. But if they're the same angle, then these two algebraic expressions must actually be equal. So if we equate them like that, we form an equation in x that we can then go on to solve. Firstly, we've got x's on both sides. So let's simplify it a little bit by subtracting 2x from both sides. So if I take 2x from that side, they'll disappear. If I take 2x from the other side, it's going to leave me with 15 is equal to x minus 38. Okay, now all I need to do is add 38 to both sides. You'll see that minus 38 plus 38 are going to cancel each other out, leaving you with x on the right, and on the left 15 plus 38, that's 38, 48, 53, isn't it? That tells me that x is equal to 53. A is a common factor of 72 and 120, and B is a common factor of 6 and 9. Work out the highest possible value of A over B. Okay, so this fraction is going to be its biggest when A is at its maximum value and B is at its minimum value, isn't it? Okay, you'll get a bigger number if you divide a fraction by a smaller denominator. So let's take B to start with then. I think that one's going to be easier. A common multiple of 6 and 9. If we want B to be minimum, we're actually asking for the lowest common multiple of 6 and 9. Okay, so let's think about the multiples of 6 and 9. The multiples of 6 are 6, 12, 18, and so on. And 9 is 9, 18, 27, and so on. So you can see we found our lowest common multiple already. 18 is there, 18 is there, so our LCM then of those two numbers is 18. So that's going to be my value of B. What about A then? We've got A is a common factor of 72 and 120. So let's list out the factors of 72 and 120. I tend to write them down in factor pairs. So 1 goes with 72. 2 goes with, well, half of 72 is 36. I think 3 must go into it then as well. So 3 and 24, is that? 3 and 24. 4 and what? 4 and, that's got to be 18, isn't it? 5, no, 6. Yeah, 6 goes into it. 6 and 12. 7, no, 8, yes. 8 goes with 9. And look, I've met myself coming down the other way, so that's as far as I'm going to get. So quite a lot of factor pairs of 72. What about 120? We're going to have so many. So I've got 1 and 120. 2 and 60. 3 goes with 40. 4, yes, goes with 30. 5 goes with 24. 6 goes with 20. Also got a lot of factors. 7, no. 8, yes. 8 goes with 15. 9, nope. 10, yes. 10 goes with 12. And then I've got 11 in between. That's not going to be a factor. So that's all of them. Gosh, lots of factors for both of those numbers. So we want the HCF then of those two numbers. So we want A to be as big as it can be. So it's going to be the highest common factor of those two. So looking through my list, 72, no, 36 is my next biggest. That isn't on my list. 24, yeah, that's on my list. So look, 24 there, 24 there. So the HCF of these two numbers is 24. Okay, so what's the highest possible value of A over B then? Is going to be, so that was my A value, wasn't it? 24, and B is 18. So my highest value is going to be 24 over 18. Okay. Which I could cancel down, but I'm not sure I need to. So it could simplify to 4/3. Also an acceptable answer. In the diagram, DC is parallel to AB. So DC is this line here, AB is this line here, and you can see that they are parallel. Okay, so I've got a pair of parallel lines. It's not a parallelogram. Looks a bit like one, but those other two lines are not parallel. Now it asks me here to show that the triangle ABD is isosceles. So where's ABD? ABD is ABD, this triangle here. That's the triangle I'm looking for. And I need to show that it's isosceles. In other words, I need to either show that the lengths of two sides are equal. I'm not going to be able to do that. Or I can show that this angle and this angle here must be equal to each other. Okay, so I know the angle at the top is 124, so I need to show that this angle here then and this angle here are going to be isosceles. Are going to be equal to each other and therefore isosceles. Okay, so how am I going to do that? Well, let's have a look at the other triangle first, the triangle BCD, which is, I'm making a bit of a mess of this diagram. It's this triangle over here, look. Okay, so the blue triangle, I know 2 out of 3 of the angles from the blue one. I've got 152. So the angle at the top there, this angle up here, is going to be, well, the angles in the triangle add up to 180 degrees, don't they? So my 100 plus my 52 plus my angle there equals that angle there, doesn't it? So I know that that angle is equal to 180 minus the other 2. So it's going to be 100 plus 52. 100 plus 52 is 152. So 180 minus 152, what's that equal to? So 180 minus 52 is 180 minus 150 is 30, and 30 subtract 2 is 28. So that angle there is 28 degrees. Okay, so I know that one's 28. How's that helping me? Well, when you've got a pair of parallel lines and a line crossing them, then the angle there and the angle there we call alternate, don't we? And we know that alternate angles are equal. So that angle is going to be the same as that one down there. So on this diagram, that 28 is going to be the same as this angle down here then, isn't it? That one there is 28 because they're alternate. So I now know that that angle there must be 100, that is 28. So then this angle up here then, again, is going to be 180 subtract the other 2. So 180 subtract 124 plus 28. So 124 plus 28 is what? 124, 144, 152, isn't it? 180 minus 152. Oh, look, that's equal to 28 as well. That's also equal to 28. Okay, so we've shown then that both angles are 28 and therefore is isosceles. So we can say that angle ADB is equal to angle ABD, and that's equal to 28 degrees. So triangle is isosceles. Okay, done. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.